Hello friends, welcome to the Industrial Classroom. I am Ritesh and today we will learn on the topic of conveyor belt. Today we will not go into much depth but we will learn the basics of the conveyor belts, the components that are present, and we will just have a brief overview of the belting system. Okay, so the first thing is, what are the conveyors? What are conveyors? Conveyors are of various types. We will look into those. But beforehand, let us first know that what are these? Conveyors are mechanical systems which are used to transport materials, products or goods from one place to another. So whether it be a moving line, a packaging line, a product line, a supply line, or in various industries like production, shipping, relocation, manufacturing, mining, you need to ship products, to transport products from place 1 to place 2. For example, from here to here you want to ship this. So you have two options. Either you go through the vehicle route, or you can go through manual mode where persons will carry the things, or you have the system to use conveyors. So we will look at the types of conveyor before we go into the benefit of using conveyor over vehicles. So what are the types of conveyors? The majorly used conveyor in the mining industry is the belt conveyor. Next we have chain conveyors, then we have roller conveyors, screw conveyors, overhead conveyors, pneumatic conveyors. Belt conveyor you can find it in any manufacturing unit, or you can find it in mining industries. Chain conveyor you will find it in food industries, packaging industries. Roller conveyor also you will find it in the manufacturing industries, packaging industries. Screw conveyors you can find it in manufacturing industries, especially in the rasa circuit or the slag circuit, where they used to separate the slag from the water slag mixture, right? And then in the overhead conveyors you can find it in the meat industry. Okay, here from the slag they separate the powdered mixture or the powdered slag mixed with water. Pneumatic conveyor you can find it in spray systems or paint industries. Vibratory conveyors are also used in mining industries. Bucket conveyors, remember that these bucket conveyors are not the bucket belt conveyors. These are the stainless steel conveyors. These are of different types. These are different from the bucket belt conveyor. Next we have spiral conveyors. Okay, so what are the benefits of using conveyors? Why don't we use vehicles, or we may use some trucks or lorries to transport material from one place to other, but why do you use conveyors? So now let us look into the most important topic that we are reading here. We will dive into this only, that is the belt conveyor. So why do you use conveyors if you have trucks to transport material? First is lower operating cost. How does the operating cost lowers? The cost of consumption of fuel, the cost of maintenance, these are all the operating costs. Now continuous operation. A truck will move from place 1 to place 2. Okay, it follows this path. But a conveyor, by the use of conveyors, here is the discharge point, here is the receiving point, and here is the discharge point. This will be a continuous operation. So it will be a continuous operation. By using conveyors we can provide continuous operation. Reduced congestion. We have to suffer a lot of traffic jams, especially when we have much amount of vehicles or during the time of congestion. So in conveyors we can prevent this, because we have a single route, there are no traffic jams, right? Increased efficiency. Increased efficiency means that you can produce, this is also somehow related to continuous operation and the timing. Increased efficiency means you can control the amount required, you have the time with you, you can handle various operations, right? The amount, the time of supply, and continuous production. Environment friendly. When it comes to vehicles, we generally have to suffer from greenhouse gases emissions, but in conveyors there are no such things. Reduced accidents. In congestions, in case of jams, we have to face various type of accidents, right, from material or from vehicles or from moving machineries, but conveyors can be created in a much safer way, and they can be managed in a much safer method. Now let us look into the components of the conveyor, the belt conveyor system. So these are just a brief components. This image is carried from Google. Okay, so the components of conveyor system, if we look into that, the first thing we have is a discharge chute. Sorry, we will first move on to the feed chute, from where the material comes. The material comes from the feed chute, or we also say it as the receiving chute. The material comes and goes through a square type of cabinet or a box, which is called a skirt. Okay, here what does happen? Why do we make the skirt such longer, or we make the receiving chute skirt? It is the receiving chute skirt. Why do we make it such longer? To control the amount, of spillage material, to control the amount of dust that is generated, we use long chutes, right? We use long skirts. This skirt is used to control the material spillage overflow from the conveyor ends. Now here it is the belt. You can see the belt. These are the pulleys, and here in the head end we also find scrapers. Scrapers are used to scrape the material or remove the material that are attached to the belt, that we can say get stuck to the belt. Okay, so scrapers are used. So if this is the pulley, this is the belt moving, then we use a scraper, like the razor that you use to save your mustache or save your bird. So this scraper, what it does is, it material is stuck here, the scraper scrapes off and moves it outside. Okay, so this is the function of the scraper. Here we have head pulley, here we have tail pulley, we have different types of pulleys, we will study it later. And here we have a discharge chute. So the material pathway goes from the material will go from the receiving chute, then on the belt it is carried on various line to the end, it's get into the discharge chute. So it can go to the second conveyor, or it goes into the bin. Okay, so this is generally the pathway it follows from the receiving chute to the discharge chute. Now let us look at one components before moving on to belt. So we will first look at different accessories of the conveyor system, then we will finally go to the belting system, right? So here we have pulleys. What are pulleys? A conveyor pulley is a mechanical device that is used to change the direction of the belt in a conveyor system, to drive the belt and to provide tension to the belt. So by the use of these conveyor pulleys, what we do is we rotate the belt, we move the belt, we change its direction. Okay, without the use of pulleys we cannot use conveyor belt, because these are the driving units and this is also the driven unit. Okay, so pulleys can be generally classified into 6 types: head pulley, tail pulley, snub pulley, deflector pulley, bend pulley, and take-up pulley. These can further be classified. So what is the head pulley? The head pulley generally has the driving unit. Okay, so it is called the drag pulley. Now we have also the tail pulley. The tail pulley is the driven unit or the last end. So in one end of the pulley you can see a motor is attached. This is the head pulley or drag pulley, and the other end is the last ending portion of the belt. This pulley drives this pulley has been driven by the belt. We can also say that the pulley which drives the belt, okay, the pulley which drives the belt is called the head pulley, and the pulley which is driven by the belt is called the tail pulley. Okay, it is driven by the belt. So this can be said as the basic definition. Now we also have snub pulley. This snub pulley, we will move into snub pulley. Next we have deflector pulley, we will also look at it. Bend pulleys. Bend pulleys are used to provide a bend about 90 degree. Okay, when we come to the take-up system, we will learn what are these take-up system and what is this used for. Okay, so bend pulleys are used to provide a greater deflection to the belt. This provides greater deflection to belt. We can classify them as a head bend and tail bend pulley depending on the side. A pulley present in the tail side or the pulley nearer to the tail side is called the tail bend pulley, and the bend pulley which is towards the head side is called the head bend pulley. Now in a conveyor system you may have more pulleys here. There are also lower bend pulley, upper head bend pulley, lower end bend pulley. This nomenclature is generally provided for better understanding. Now we will look at the take-up pulley. What is this take-up pulley? See, our belt runs on the property of tension. This tensile force is the belt is provided tension. This tensile force carries the material and discharges it to the discharge chute. Right? So who drives the tension? The motor present here in the drive unit. It drives the pulley. This pulley in return provides tension to the belt, and in one side it provides a tight side, and on the return side it provides a slack side. Okay, so belt. So here it pulls the belt here, which in turn turns the tail pulley, and this continuous motion provides the movement of the belt. In the belt, to provide the tension, we use take-up. Okay, so take-up is used to provide tension to the belt. For example, you can think of a counterweight where we use to provide the tension to the belt. Now we will move on to the snub pulley, but before that let me ask you a question. What is the minimum number of pulleys required in a conveyor belt? What is the minimum number of pulleys? Is it 1, 2, 3, 4, 5? We have here about 6 types of pulleys. So what are the minimum number of pulleys? The answer is 2. We require only 2 types of pulleys. Okay, so one is the head pulley and the other is the tail pulley. Rest all pulleys are additional pulleys. They are based on the requirement. For example, we have a shorter conveyor, a conveyor of 2 meters in length. So here we don't need a counterweight and a take-up pulley to provide a tension to the belt, right? It can be provided through screw take-up or hydraulic system. So here we will need specifically 2 pulleys, tail pulley and a head pulley. So the answer is 2. Next, let us move toward the snub pulley. Okay, we know that our belt is driven by the head pulley. The head pulley acts as the driving unit for the belt, and the head pulley is driven by a motor here, right? So the belt has to move on the pulley. This pulley surface creates friction, okay, which is a very essential component for the motion of the belt. Without friction, we know that without friction there can be no motion in the belt. The belt will sleep and it will not be functional. Okay, the pulley will rotate but the belt will not move. What is the use of it? Therefore we have friction, or we can also say that to increase the traction of the belt we do lagging on it. Okay, so you have a smooth surface. Imagine a smooth surface where you are working, a slippery floor, what we will do when you go and walk without use of shoes. You go and walk on a slippery surface, you will generally fall down. But in the bottom of the shoes you can find, on the bottom of the sole basically, you can find some grips. These grips are used to increase the friction. Okay, similarly in bikes also, in the tire you can see there are cuttings. Why are these cuttings provided? To provide friction. So because friction is very important for the motion, okay, let it be a circular motion or a rectilinear motion, anything. So we know that the contact surface, as much the belt makes contact with the pulley, the more better or the more traction we will find, the more friction we will find, the more motion we will find. Okay, so therefore we can see that here in this type of image we can see that there is only, let me draw a bigger image. Okay, so let it be my pulley here. Now what I will do, that I have a belt running on its surface. Okay, so now what is the contact area? You can basically find that a very little contact area is produced here. From here the contact area is up to here. Okay, so it is possible to move the belt. It doesn't mean that this contact is very less and the belt will not move, but in order to increase the friction, what we do is we increase the contact area a little bit further. This is called the wrap angle. Okay, so a pulley is used here, a next pulley is used here, which provides a increase in the angle of the wrap or the wrap angle. This angle, previously we can say that our angle was 180 degree, right? This is 180 degree. Now there is an increase in theta. Now the total angle here is 180 degree plus theta. Now the wrap angle is increased, the pulley friction has increased, so now the driving unit will have a better grip on the belt. Therefore the pulley which is used in the conveyor system to increase the wrap angle or to increase the grip of the belt is called the snub pulley. Right? Now it is very important because especially in high tension heavy load applications we need to prevent the slippage. Therefore snub pulley is very important. Now let us look at the take-up pulley. We have understood that we need the belt is to be provided with tension. So what do we do? How to provide the belt tension? So because we know that belt is a moving machinery and it is very hazardous. We cannot just pull it by the use of ropes, or we cannot just pull it by use of hands. Therefore what we do is we use a load system, a loading system on the bottom of it, and the conveyor belt. So this is the conveyor belt. Let me draw. Here it is the head pulley, here it is the tail pulley, here we have bend pulleys, and here it is the take-up pulley. The take-up pulley is attached with a counterweight. A weight, counterweight is nothing but a weight which is used to provide the tension to the belt. So this counterweight acts by the virtue of gravity towards the bottom and it pulls the belt downward. It pulls the pulley downward, which in turn pulls the belt downward. This downward pulling of the belt provides a tension in this side, in the whole belt. So it is very important to have a take-up system. This is the example of a gravity take-up. In gravity take-up, the take-up pulley is mounted on a carriage that can move vertically, okay, by virtue of gravity. And this counterweight provides the force that is needed for the tension of the belt. So is this the only method by which we can provide take-up? What can we do in small systems where we don't have enough space? We can use mechanical take-ups there, and these are much more precise. These are much more precise and accurate system where we need to provide a minimal adjustment. Okay, here we have two components. Here we have two components. One is the screw take-up system and other is the hydraulic take-up system. In screw take-up system, what we do is we have a pulley here, a drive pulley in the tail unit. Basically we cannot use this screw take-up system in the head system, okay, because to use the screw take-up in the head system you also need to have a flexible motor. We need to also adjust because we generally keep the motor mounting side fixed, okay, so it removes all the pain of alignment and everything that can act as a barrier to the motion of the belt. Okay, so what we do is in the tail system we will use a screw here. This screw is fixed with a rigid system, or a rigid frame is present here. What we do in order to provide tension to the belt, we will just move this screw in the direction outwards from the belt. So when we rotate the screw, what will happen? Eventually the pulley will shift from one position to other position. Okay, this shift creates tension. To reduce the tension, what we'll do is we will loosen the screw. This will reduce the tension. So here you can see that here we have a screw system. This is the adjusting screw. We have take-up bearing, we have take-up frame. These are not essential, but we need to remember how this works. Right, this is the adjusting system. Now next we will look towards the hydraulic take-up system. See, what is the hydraulic take-up system? In hydraulic take-up system, a hydraulic power pack is used which actuates the cylinder, and this cylinder provides the tension. Okay, so in the cylinder what I will do is, here I have power pack system, hydraulic power pack, and this is the cylinder. I have an actuator here and my pulley driving unit here. So what I will do is I will provide a motion into the cylinder, and the actuator will retract backwards, which in turn will pull the pulley towards itself. This will provide tension. So here it is to be remembered that these are precise things. These are for maintaining small, means we can say that these are for maintaining small take-ups. These are for maintaining small adjustments. Okay, we cannot provide big larger adjustment with this because these are mechanical components, and all mechanical components need some support. In gravity take-up we can have a bigger larger amount of adjustment as required, but in mechanical take-ups we won't find that. Next, what we know that in the gravity take-up there is a confusion between the horizontal gravity take-up and the vertical gravity take-up. Remember that horizontal gravity take-up and vertical gravity, we have seen this type of take-up in the previous example. This is the vertical take-up, a simpler one where the load is hanging downwards and the belt is also hanging downwards. The take-up is downward. Okay, so this is the vertical take-up. But will the horizontal gravity take up if my counterweight acts horizontally? How would it act horizontally? It won't, because the gravity take up uses gravity, and for gravity we know that mg, that is the gravity which acts downwards, it acts towards the earth. So it basically needs to be vertical every time. So what differentiates between the horizontal gravity take up and the vertical take up? The position of the take up pulley. It's not the tail pulley, it's the position of the take up pulley generally differentiates. See, here we can see that the take up is in horizontal position. The belt, it is the belt. The belt is in horizontal position. This take up pulley is pulled by sheave pulleys, and this is the wire rope. These are sheave pulleys. Okay, so here we can say that here we have a trolley system on rail, and this is my take up pulley. This is the belt. I am pulling this take up pulley this side, and then I am attaching a counterweight here. So what would happen that whenever the adjustment is done, whenever I need to do some adjustment, I will simply loosen or tighten the counterweight here. इसको what we'll do is we will, the counterweight will move upwards and downwards, and this adjustment will be in the horizontal side, right? So this arrangement of the take up pulley, where the take up pulley is in horizontal position, the belt is in horizontal position, it is the horizontal take up. In vertical take up you will find the take up is in vertical position. This is the only difference. We have learned that by increasing the wrap angle we can increase the friction. We also know that a plain pulley doesn't have any cover. It has a metal said on it, a plain metal or a steel we can say. Okay, so this is the disc. This is the cylinder of the pulley, and it will generally slip if it doesn't have any friction. A metallic plate, a metallic sheet will not have enough friction to grip the belt. Okay, therefore we use lagging. Lagging are external coverings, okay, which are used to provide friction to the belt. We have four types of lagging generally in use. That is the plain lagging. It is the most simpler way of lagging. Then we have diamond lagging. These you can see are the diamond cuts. Next we have button laggings. These are nothing but cylindrical buttons on the plain lagging. Okay, so whenever on plain laggings we have cylindrical buttons, it is called button lagging. And in ceramic lagging, these are the most used in head pulleys. These provide sufficient grip. Okay, these are rubber, these are ceramic tiles which are embedded on the rubber, hot rubber. Okay, so these are the ceramic lagging, this is the plain lagging, diamond lagging. These are different types of lagging which are used in on the pulleys. Now let us move towards the idlers. Idlers are the supporting structure as well as the rolling element. Okay, These are also the supporting structure as well as the rolling elements and play a very crucial role in the motion of the belt. We know that our belt runs straight, but what would happen if you were transporting diamond? For example, if you're transporting diamond on a conveyor belt, then you can see that after it discharges from the receiving chute, the diamond will spill and fall outside. You will have so much of losses. For a manufacturing unit, the diamond is are the golds, the iron ores, everything. These are very important because they have a high cost, they have a high value. Therefore, not only in case of diamond but in case of any material where this material play a very important role, we have a troughing idler. They provide a trough safe so that the material will remain inside these and they won't spill or fall off. So these are the troughing idlers. They have angle, maximum angle here, remember that it must be 45 degree maximum angle. So minimum angle it can be 5 degree, 10 degree according to the transition type. Next we have impact idler. The material falls from too much of height from the receiving chute and it gets loaded on the belt. Here we have idlers. So what we will do? The material will get broken off. To smoothen the impact, to reduce the impact, here we use a rubber protection on the conveyor belt rollers or the idlers. So these are the impact idlers. Flat idlers, these are simplest type of idlers, and tracking idlers. We know that belts are very longer, especially it can go up to several kilometers also. We need to track these to move them in a straight line, okay, so that they don't just go out of the idler. Okay, so that they just don't move out of the idler and move here and there. Okay, to prevent its movement in the similar directions. Remember that this tracking idler is for tracking the belt, not for material. To track the material we have the troughing idler. To track the belt we have the tracking idler. This provides a straight motion to the belt. Similarly, in the return side, we may find flight return idler, we may find V-return idler, we may also find return tracking idlers. The tracking idlers in these belts are also known as troughing tracking idler, or we call it as TTI, troughing tracking idler, or these are also said as aligning idlers. There are several names to it of it. Now we know that conveyor belts also have sticky material. To remove sticky material, there are also flat disc idlers which removes the sticky materials. Okay, so whenever the belt these are generally provided in the return side. Okay, because on the flat side is in the carrying side we have in the carrying side. Okay, so what is the carrying side? The side on which material falls and which carries the metal is the carrying side. After it gets discharges into the discharge chute, now the belt that comes here which does not carry any material, this is the return side. Okay, in the return side we may have some sticky materials. These are removed by the flat disc idler. So now what are the factors which affect the selection of conveyor belts? What are these factors? If we look the factors of the selection of the conveyor belts, we can know that the material to be conveyed. What is the material that needs to be conveyed? The selection depends on it. We have various type of conveyors. We will look into it. We have pipe conveyor, we have bucket conveyor, but all of these depend on the material to be conveyed. Right? This material also depends on the lump size. What is the lump size required? What is the shape of the material? What is the size of the material? These all come under the material to be conveyed. Next we have inclination of the conveyor. How much inclined can a conveyor be? Can we place the conveyor at an angle of 60 degrees here? So this is also a very important factor because the material will generally slip off. Therefore inclination is also important. Next, conveyor speed, conveyor length, environmental conditions. Environmental conditions means temperature, then wind, humidity, moisture. All of these things affect the selection of the conveyors. Space and layout factors, whether you have ample amount of space or you do not have much space. This and the economic factors. Rest economic factors means the cost. Okay, so you would think that I need a simple conveyor to transport you may need a simple conveyor to transport a pile of books. Okay, a conveyor in a packaging industry to transport a pile of books from one place to other. But what you have done is you have brought a bigger size conveyor with steel cord embedded in it with metal breaker and everything to provide to transport these books. Is it required? Is it required, or are you adding to the burden of the company? So this is the economic factor. Next, when we come to the belting system or the conveyor belts, okay, these are conveyor belts what we have learned in the previous, in this module. This is the, we have now come to the belt conveyor, right? This one, belt conveyor. So in the belt conveyor, we have different types of belt conveyors. We have flat belt conveyor, we have dropped belt conveyor, we have pipe conveyor, we have chevron conveyor, we have bucket conveyor. Okay, so where are these used? Let me just provide simple examples. Flat conveyors are very efficient. We will use it every time. If we don't need material troughing, if we need to transport just simple materials which don't spill back, then we will use the flat conveyors, because it is very simplest, very easy to manufacture, and very much economic. Okay, very much economic. Therefore, I will use the flat belt conveyor. But when it comes to provide, when it comes to spillage material which will spill off and which will move out of the conveyor, which will not stay in the flat conveyor, we will have a troughing conveyor. Pipe conveyors are generally used when we have dusty materials, that is fine dust or minerals or powders which we will need to transport. So we will transport them in these pipes so they don't spread off. Chevron conveyors are generally used for transporting rolling elements or rolling materials. So rolling materials, when we will travel by the trough conveyor, they will slip off and roll off. So when it will reach the discharge chute, you will find that there is no material. Everything is rolled off here. No efficiency. Finally, what we will do is we will make some steps here, a design. This is the V-shaped design. These are the chevron belts which collect the material and pick them here, put them here, right? Next is the bucket conveyor, when we need to transport materials 70 degree, 90 degree. So what we will do is we will transport them by bucket conveyors. These are more efficient here. These are buckets. The material fall here and they cover them, discharge them. Okay, they discharge them in the receiving discharge chute. These are the different types of belt conveyor. So now a very important thing that we must learn here is the fabric belt. How are these fabric belt constructed? How are these? What is the composition of the fabric belt? When we come to fabric belt, we have top cover. We have top cover. We have carcass in between, and we have bottom cover. These are the three main components: cover rubber, carcass, top cover, bottom cover, and top cover. This is top cover. This is the bottom cover, and in between we have the carcass. Okay, we have the carcass here. So top cover, carcass is, remember that what is the most important thing here? Carcass, because it will carry the entire load. Carcass carries the entire load, so we have the main element in carcass. So carcass can be constructed of NN or polyamide. It can be constructed of EP, what we call it as polyester polyamide, or it can be constructed of cotton also. It can be constructed of various other fibers, but these are the most used. What are the cottons? See, these are nothing but you can see your cloth. One layer of cloth, two layer of cloth, three layer of cloth, four layer of cloth. These four layers of cloth along with some Fevikwik or Fevicol, you can say sticky elements, what we call it as skin here. These are called the carcass. These totally combined together to form a carcass. Each cloth that you are using, you can say at these as ply. In the conveyor line, we say it as ply. These are plies. So we have used, here you can see that how many plies we have used: 1, 2, 3, 4, 5. It is a 5 ply belt. Okay, so here the total ply, and in between we have some attaching, these are bonding elements. These are called the schemes. Okay, they are used to fix, they are used to embed the ply together. They will totally form a single element, and this combination of 5 ply plus interbonding or the bonding material or the scheme will combine to form the carcass, right? So if this is the main material carrying element, why do we have these covers and bottom cover and top cover? Remember that top cover and bottom cover protect the carcass. You have bones, you have blood, you have everything, but don't you have skin above it? What does the skin do? It covers the entire body. It protects the internal organs. So this is the similar way the rubber protects the internal elements. Cover rubber. Okay. So We will look into this in the next class with great depth because now it's time. Okay, we will look into this because we will have this specification. Remember that this is the first class and in the second class we will look into much depth. Thank you so much. Keep attending and stay tuned. Thank you.